Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS 3301 Data Structures. The unit is list. In this video, we are going to discuss about list ADT. List ADT. The list is a collection of elements in the sequential order. In memory, we can store the list in two ways. First one is a sequential memory location, then that means array. Then second one is a pointer to link, that to associate the elements sequential. It is known as linked list. The list ADT means list is an ordered set of elements. The general form of list is a A1, A2, A3, like this up to AN. Here the A1 is the first element of the list, then AN is the last element, the N is the size of the particular list. If the element at position I is AA, then its successor is AA plus 1 and the predecessor is AA minus 1. The various operations performed on list are, first one is the create an empty list. This is the first operation. Then second, print list. This operation is used to print all the elements in the list. Construct a copy of the list. Then next one is the find of X. This operation returns the position of the first occurrence of the particular element X. Then remove of X. That means this operation is used to remove the X element from the list if present. Then insert of X comma position. This element insert the X into the list at the specified position. If it is empty, that returns true. If it has no elements. Then next one is the make empty. This method is used to remove all the elements from the list. Then find kth int of S, that returns the element in the specified position. Then next one is the linked list. The linked list is a collection of data element called nodes in which the linear representation is given by links from one node to next node. Then the reason for linked list. Why the linked list is used? Array is a linear collection of data element in which the elements are stored in the consecutive memory location. While declaring array, we have to specify the size of the array, which will restrict the number of elements that can store. For example, if we declare an array as int marks, then the array can store the maximum of 10 data element, but not more than that. But what if we are not sure the elements of in advance? So there must be data structure that removes the restrictions on the maximum number of elements and the storage condition to write the efficient programs. The advantage of using linked list or a linked list does not store its element in consecutive memory location and user can add any number of the elements to it. However, unlike an array, a linked list does not allow random access of data. Elements in the linked list can be accessed only in the sequential order. But like an array, insertion and deletions can be done at any point in the list in a constant time. Some of the basic terminologies used in the linked list. A linked list, in simple terms, a linear collection of data elements. The data elements are called nodes. The linked list is a data structure which it in turn can be used to implement the other data structure. Thus, it acts as a building block to implement the data structure such as stack, queue, and their variation. A linked list can be perceived as a train or a sequence of nodes in which each node contains one or more data fields and a pointer to the next node. The linked list provide an efficient way of storing related data and perform basic operations such as insertion, deletion, updation of information at the cost of extra space required for storing the address of the next node. In the above figure, we can see a linked list in which every node contains two parts. First one is the integer and the second one is a pointer to next node. The left part of the node which contains data including a simple data type, array or data structures in its structure. The right part of the node contains a pointer to the next node. The address of the next node in sequence. The last node will have no next node connected to it, so it will store a special value called null. In the above figure, the null pointer is represented by using x. While programming, we usually define null as -1. Hence, a null pointer denoted the end of the list. Since suppose if it is a linked list, every node contains a pointer to another node which is the same type. It is also called the self-referential data type. Then use of start pointer variable. Linked list contain a pointer variable start that store the address of the first node in the list. We can traverse the entire list using the start, which contains the address of the first node. The next part of the first node in turn store the address of the succeeding node. Using this technique, the individual nodes of the list will form a chain of nodes. If start equal to null, then the linked list is empty and contain no nodes. This is a sample code for linked list. First one is a struct node. In the inside this int data, that means data to be declared in integer. Then next one is a struct node star next. This is a pointer representation of the linked list. Memory representation of linked list. Let us see how a linked list is maintained in the memory. In order to form a linked list, we need a data structure called node, which has two fields. First one is data, then second one is next. Data will store the information part and next will store the address of the next node in the sequence. Consider the then next one is a free pool and avail pointer variable. The computer maintains a list of free memory cells. This list available space is called free pool. We have seen every linked list has a pointer variable, that is start, which stores the address of the first node of the list. Likewise, for the free pool, we have the pointer to the avail, which stores the address of the first free space. Then this is a memory representation of the linked list. At first, the start it denotes the first initially starting of the starting data. Then next, suppose inserting a new node using the available will set to contain the particular address. This was what about inserting a new node. This is an already existing linked list. We will discuss the deleting node or the entire linked list. So the operations does not task of adding the free memory to free pool. The operation will perform these operations whenever it finds the CPU idle or whenever the programs are falling short of memory space. Then it collects all the cells which are not being used and adds their address to the free pool so that these cells can be reused by other programs. This process is called garbage collection. Thank you.